There is a lot to cover in triangles, so let's just go ahead and get started. First, there are a couple ways that we can classify triangles. The first is based on side lengths. An equilateral triangle has all sides of the same length. You can see this using the tick. If the sides are the same length, they're going to have the same number of ticks. We have isosceles triangle where exactly two sides have the same length. So the third side is going to be longer or shorter. Scalene triangle, none of the sides have the same length. You can see that because there are no ticks around, so there's nothing showing that any of the sides are equal. They might look kind of equal, like this side looks like it might be equal to this side, I don't know. But because there are no ticks showing it, we can assume that they are not. We can also classify triangles based on angles. An obtuse triangle has one obtuse angle inside. A right triangle has a right triangle inside. Again, remember that right angle is only denoted by that square. If that square isn't there, you cannot assume that it's a right angle. An acute triangle, all three angles are acute. So let's classify each triangle by its side and its angles. So let's see. We have a right angle, so it's a right triangle. Oop. Now let's look at the sides. We have a 14.1 meter, 10 meter, and 10 meter. So two sides are equal. That makes this a right isosceles triangle. Let's look at this one. We have an acute, oh, that's an obtuse angle. So this is an obtuse. And do any of the lengths equal? No, this is an acute, or an obtuse scalene. See, an equilateral triangle, right? Because we have four equal sides, but all of the angles are acute. So this is an acute equilateral. Would there ever be a time when an equilateral triangle would not be acute? No, there wouldn't. There is absolutely no way for that to happen. No matter how big the sides get or how small they get, these angles are all going to stay the same size. So all equilaterals are actually acute. So there are two rules when it comes to angles and triangles. The sum of the angles has to equal 180 degrees every time. 2, if any sides of a triangle have equal lengths, then the angles opposite those sides will also have equal measures. So we kind of understood that a bit in this equilateral triangle because all of the sides are equal, all of the angles are probably equal as well. So let's look at this example. Find the measures of the unknown angles in each triangle. Well, we have 53 degrees. This box is telling us that that's 90 degrees. So what's this angle? Well, we know they all have to add up to 180 degrees. So 180 degrees must be the sum of these angles. We'll call that unknown angle x. So 180 degrees equals 143 degrees plus x. So what does x equal? Let's grab our calculator. 37 degrees. How about this next one? Well, we know all of the angles has to add up to 180. So let's add what we know. We'll subtract 83 from both sides and we get 97 degrees as our missing angle. Number 3 looks kind of tricky. We're actually missing 2 angles here. However, we did learn in our second rule that the opposite angles of sides that are equal have equal measures. So these 2 angles equal the same thing. So we have, let's call this one x. This one is also x because it's the same angle. So we're going to take 180 degrees and it equals 134 plus x plus x. So 180 degrees equals 134 plus 2x. Subtract 134 from both sides, and we get 46 degrees equals 2x. So 23 degrees equals x. So each of those angles is 23 degrees. How about number 4? Well, this box says that that's 90 degrees. This is x, this is x. We'll solve this the same way we solved the previous one. 180 degrees equals 90 plus x plus x. Combine our like terms. Subtract 90 from both sides. So x is 45 degrees. This is going to be true for any right isosceles triangle. Those 2 angles are always going to be 45 degrees. How about this last one? We have an equilateral triangle. So we have x, x, and x. Well, we know that these are all the same angle because the opposite sides are the same, then the angles are the same. So we have 180 equals x plus x plus x. We'll combine our like terms. Divide both sides by 3, and we get x equals 60 degrees. And that's going to be the case for any equilateral triangle. The angles are always going to be 60 degrees each. Let's take a look at similar triangles. A similar triangle is where they're the same length, or they have the same shape. They have all the same angles, but the lengths of their sides are different. So we're actually going to be using proportions that we learned in the last unit to figure out these similar triangles. So ratios and proportions, they are coming back to haunt you. We have this length that is similar to this length somehow, this length that is similar to this length somehow, then the W is similar to 25 somehow. We just have to figure out what it is. Let's take this side and this side, figure out the ratio, and set it equal to this side versus this side. So we'll have 21 over 15 equals W over 25. Well, 21 and 15 are both divisible by 3, so I am going to take this and make it 7/5 equals W over 25. We can simply multiply both sides by 25. One of the 5's is going to cancel out here with the 5 on the bottom. We have 5 times 7 is 35 equals W. How about this one? This one looks really weird. It's not lined up exactly the same as the triangle below it. But if we redrew it, Now we have the right angle in the same area as the right angle. Make sure we label everything the same. The longer side that's adjacent to this right angle is D. The shorter side is 100. We're trying to find D, the distance here. Well, let's look at ratios again. The shorter length to the shorter length, so 25 to 100, is equal to the longer length to the longer length, 67 over D. Let's simplify this fraction first. This is 1/4 equals 67 over D. Let's multiply both sides by D. We get D over 4 equals 67. Multiply both sides by 4 and we get D equals 268. There's our answer. Go ahead, pause the video, and you can work on problem number 9 on similar triangles. All right, next we're going to go over the Pythagorean theorem. We had talked about the Pythagorean theorem briefly when we were talking about the distance formula between 2 points on the coordinate plane, but now we're going to use it in terms of geometry. Again, the formula is a squared plus b squared equals c squared, where c is the longest side. And again, remember, this only works with right triangles. So don't try using this formula with obtuse or acute triangles. It has to be right. So we are going to use the Pythagorean theorem to determine whether this triangle is a right triangle. It looks like it could be, but it doesn't have that square there, so we don't know for sure. So we're going to square the two shorter sides and see if they equal the square of the longer side. So we'll have 5 squared plus 12 squared equals 13 squared. 5 squared is 25. 12 squared is 144. 13 squared, I believe that's 169, but I'm going to double check. 169. Add these two together, we get 169 equals 169. So yes, it is a right triangle. Let's look at the next example. Now we're going to find the missing side. So let's use the Pythagorean theorem to find the missing side here. So we're going to square the two shorter sides, set it equal to the longer side, which we're going to call x. 8 squared plus 6 squared equals x squared. 8 squared is 64. 6 squared is 36 equals x squared. Add those together, we get 100 equals x squared. Take the square root of both sides, we get 10 equal to x. Now when we take the square root in geometry, you never have to worry about the negative. It's always going to be positive. Lengths are always positive in geometry. Number 2, now we're missing a shorter side. So we are going to have to take 8 squared plus x squared and equal 17 squared. 8 squared is 64 plus x squared and 17 squared. I'm not even going to pretend to know that one. 289. Let's subtract. Minus 64 equals 225. We'll take the square root of that and get 15. So x is equal to 15. Pause the video here. Take a look at some of these, and they are going to be similar to what we just did. You can resume the video after you've completed them. And that's it. We are going to move on to polygons next, so I will see you then.